Okay, this is the last question in the calculus workshop. It's the fourth question we're going to do. It's a little bit trickier and it's got some nuance in it here. So let's, November 2019 is where it's from. It's the last part of the first calculus question. Let's just try it. They say there's this function that's called y equals x plus 12 over x. So it's some kind of curve. I don't know what kind of curve it is, but it passes through a point, which is 2 and some y value b. Determine the equation of the line perpendicular to the tangent of the curve at A. Holy cow, that's a perpendicular tangent. What's going on? Okay, this is what you do. When they say the tangent to a curve, it's a line that you push up at that point. There's a line, a straight line, and it touches the curve at A. It's called the tangent line. We can get the gradient of that line if we just find the derivative here. We can also get B here pretty easy. All we have to do is take 2 and put it in for x, and we'll get the y value. So that's kind of easy. In fact, we put 2 there, 12 divided by 2. We can see b is 8, and we're probably going to need that. That's one thing to do, but you have to put a 2. They say this question's worth 4 marks. It feels like it should be worth 6 or 7 to me, but anyways, there's 2. You put a 2 in there, you could get that b is 8. That's one thing. But we have to find the derivative. But remember, we can't find the derivative of 12 over x. We have to put this in the form of x to the minus 1. That's your first step. Now we can find the derivative. We go minus 1 times 12 is minus 12. We subtract 1 from minus 1. The derivative of x is 1. 1 times 1 and bring it down 1 is x to the 0. It just falls away there. It's 1. Well, there's y prime. There's the derivative. But we can find the gradient right there if we put 2 in there. So let's try that. If we put 2 into this derivative function, we're going to get the gradient of the tangent line. Well, let's do that. We go 12 over 2 squared. Well, 12 divided by 4 is 3. 1 minus 3. The gradient is negative 2 right at this point 8. But they said, okay, and we can find what the b value is just by putting x is 2 in there. 2 plus 12 divided by 2. 2 plus 6 is 8. Okay, that's some information to go on. We know that a is 2 and 8. We know the gradient right there is minus 2. That's quite a bit to do. But gee, they asked for the equation of the line perpendicular. Well, the gradient's minus 2. How do we find a perpendicular gradient? Well, maybe you remember minus 2 over 1. You turn it upside down and you change the sign. That's how you get, if you've got a gradient of minus 2, then the perpendicular gradient is 1 over 2. You turn it upside down and you change the sign. Minus 2 over 1 becomes 1 over 2, and you change the sign. Hopefully you remember from grade 10 how to find a perpendicular gradient. Well, holy cow, that's pretty good. We've got the gradient, we've got a point, we can find the equation of the line that goes through that point. And all we have to do, the line is y equals 1/2 x plus c, because that's the gradient of the perpendicular. All we've got to do is put 2 in for x, 8 in for y, solve it, we take away 1, we get c is 7. Bingo, we've got our equation, y equals 1/2 x plus 7. That's the equation of the perpendicular line to the tangent. First, we had to get the gradient of the tangent, and then we had to find the perpendicular gradient, but we know it's going right through that point, so we use that point and put it in to the equation we know is 1/2 x plus some y-intercept. We get the y-intercept of 7. We've got the equation of that line perpendicular to the tangent right there at A. Ooh, that's a lot to think about. I don't even know what this curve is, but I know all this stuff is right. Okay, I hope that helps.